Good day. Our lesson for today will be about the exponential growth and decay, an application. So why an application? This will be an application of what we have learned in differential equations. So for our learning competencies, we have the learners are able to solve problems involving in anti-differentiation and solve situational problems involving exponential growth and decay. So for our learning objectives, we solve situational problems involving exponential growth and decay. So for our first tasks, so let's tell whether the following situations represent a loss or a gain. So we will be using this concept in our lesson for today. So the population of a certain city is now 1,234,000 from 535,343. So sabi, galing siya sa 1,234,000, kumonte, naging 535,343. So this will be so this represents a loss. Okay, next. We have the evolution of Microsoft Office from MS-DOS to Microsoft Office 2020. So evolution, so meaning, okay, nag-upgrade from MS-DOS, naging Microsoft Office 2020. So this is obviously a gain. Now next, we have, okay, number 3, the weight of Miss Garcia turns to 45 kilograms from 65 kilograms. Okay, so napakadali lang sabihin, okay, or i-represent ang numbers from 45 to 65. So tumaas, that is a gain. So number 4, the change of a certain element into another element when the amount of material remaining after 10 years is 20 grams from 100 grams. So kung iintindihin natin, mahaba man yung sentence, okay, pwedeng mag-focus tayo sa huling phrase, 20 grams from 100 grams. Okay, so kumonti daw, that is a loss. Now, the amount of money, number 5, the amount of money invested is 10,000 pesos and earns an interest of 1,255 after 1 year. Okay, so dito naman, nag-invest ng 10,000 and nag-earn ng interest ng 1,255 pesos. Okay, so nadagdagan yung kanyang pera. So naging 11,255 pesos na. So that is obviously a gain. All right. So I hope this is clear to us. Okay, so we will be using this concept in our lesson. All right, so now let us move to our lesson for today. So when one quantity grows up and the other quantity also grows up represents an exponential growth. Okay, so yung mga example natin kanina, yung mga nakadepende sa time, okay, and then they grow up, okay, or nadadagdagan ng amount. So that is called the exponential growth. So one of the famous situational example of this kind of change is the computation of the interest of the money invested. Okay, so yung example number 5 natin kanina, nag-invest ng 10,000 and then nag-earn ng interest na dagdagan yung kanyang pera. So that is an exponential growth. So we all know that as year goes by, the principal amount, okay, or yung ininvest na pera, principal or the initial amount invested is increasing. Okay, so other examples like increasing number of population, ayan, magagamit natin yan, makaka-encounter tayo mamaya sa ating mga examples ng exponential growth. Okay, so yung nag-increase yung number ng population, nag-increase yung number ng bacteria. Okay, so this shows the exponential growth pattern. Okay, so now, when one quantity, kabaligtaran naman itong nasa second paragraph, goes up while the other quantity goes down, that represents an exponential decay. So anong meaning nitong one quantity goes up while the other quantity goes down? Okay? Itong patuloy na tumataas, okay, represents the time. Okay? Habang lumilipas ang oras, hindi naman tayo pabalik, di ba? So laging pa-move forward ang time. Okay? So it increases. And then yung quantity natin ay bumababa, okay, or the amount. So that represents the exponential decay. Habang lumilipas ang oras, kumukonti yung ating amount, decay ang tawag doon. Okay, yung kanina, habang lumilipas yung oras, nag-i-increase yung amount, growth ang tawag. So, example na exponential decay is when the rate at which the material is lost from its original amount. Okay, other example like the change of radioactive substance to another element shows exponential decay pattern. So mamaya maka-encounter tayo ng mga examples na yan. So isa pang example nito ay ang rate or depreciation. Okay, so bumababa yung pera habang lumilipas ang panahon. Okay, so ayan. So exponential growth and decay can be described by the exponential function a of t is equal to a sub o e raised to kt. Okay, so mamaya, wag muna nating intindihin yan. So let us derive naman yung ating formula ng exponential growth and decay. Okay, so dito i-apply natin yung natutunan natin sa ating differential equation. Okay, so let A be the amount quantity. Okay, so A yung amount or the quantity or yung dami. So meron din tayong K which is the rate, the constant rate, and then we have T for the time. Okay, so now it exhibits, okay, yung ating mga problem that the change of the amount with respect to time, represent nyan ay dA over dt is equal to a constant amount, K, multiplied to the amount. Okay? So, anong sinasabi ng dA over dt is equal to K multiplied to A? So, the amount grows. So, dumadami or nagde-decay. Okay? Nagche-change yung ating amount, change in the amount with respect to the time. Okay? So, proportionally at a constant rate at some time t. Okay? So, as A increases, okay, habang nag-i-increase yung A, So nag-i-increase din yung ating dA over dt. That is if positive yung ating k. Kapag negative naman yung k, as a increases, so yung change natin decreases naman. Okay? So we apply. So this k is the rate, and then this is the amount, the present amount. Okay? So kung mapapansin natin sa formula na yan, okay, sabi dyan, ulitin ko lang, yung change sa amount ng ating example ay nagbabago at a constant rate. Okay? That is when multiplied to the present amount. Okay? So habang nagbabago yung oras, magbabago rin yung ating amount. Okay? So apply natin yung ating differential equation. So dA over dt is equal to Ka. So we have, multiply natin sa dt para ma-cancel siya sa kabilang side ng equation. So dA is equal to Ka dt. Okay, meron tayong Ka dt. Itong A na to, kailangan niyang mapasama dito sa ating dA. So divide both sides by A. Okay, hindi siya dapat kasama ni dt dahil hindi the same ang variable. So we have dA over A is equal to d, na-cancel si A dito sa kabilang side. So we have K dt. So now, dA over A is equal to K dt. We have manipulated our equation. So we can now integrate both. Okay, so dA, integral ng dA over A is just the natural logarithm of A equals, yung K is a constant, so pwedeng ilabas. K integral ni dt is simply t. Okay, so meron na tayong nabuong bagong formula, ln A is equal to K times T. So tanggalin natin yung ln. Gusto ko A lang yung nasa kabilang side na equation. So paano natin gagawin yon? So itong si natural logarithm natin, A is equal to KT, i-transform natin into exponential form. Okay, so itong ln A, ang ibig sabihin niyan, logarithm of E. Logarithm of A with a base E. So, E lang yung base niya and then equals sa KT yan. Itong base natin na yan, magiging base siya kapag tinransform natin sa exponential form. So, magiging ganito yan. A is equal to E raised to KT. So, naging exponent na tong nasa kabilang side na equation, tas itong E ay yung base pa rin. Okay? So, malapit na tayo sa ating final form ng ating formula, general formula for the amount. So, itong e raised to kt, pwede pa nating lagyan yan. Okay? Oops, nakalimutan kong pag nag-integrate, meron tayong plus c. Okay? So, meron niyang plus c. So, kt plus c. Alright? So, itong c na yan, at saka kt, pwedeng paghiwalayin natin yan. E raised to kt multiply to e raised to c. So, saan nanggaling yan? Sa rules of exponents. Okay? So, kapag meron tayong sum, tapos nasa exponent, okay, pwedeng, ang ibig sabihin yan, multiply natin yung same base pero magkaibang exponent. Okay? And then, e raised to c is just the, pwedeng gawin na natin yan as big letter C kasi constant din naman yan. Okay. So, ang mangyayari magiging A will be equal to C times E raised to K times T. Alright, so that will be our final formula. Okay, so na-derive natin yung formula na A is equal to C E raised to KT. Okay, meron tayong time here, meron tayong K, meron tayong K na constant rate, and then meron tayong A, which is the amount. Etong C, okay, so laging tatandaan natin, so base lang din dito, so the initial amount, ayan. So itong C na yan ay laging initial amount. Okay, so yung amount niya sa umpisa, that is the C. So we have our formula of the amount as a function of time. Okay? So magamit natin yung formulang yan sa pag-solve ng problems involving the exponential growth and decay. Okay? So A of t, we have a function here. Okay? The amount, okay, bakit quantity t? So ibig sabihin lang yan function, so hindi siya minumultiply na. So A of t is equal to A sub O, which is the C rin kanina. Okay? So pwede nating palitan na A sub O, meaning the amount or the initial amount, then multiply to E raised to KT. Then A of t is the amount or value after time t. Okay? So makalipas ang ilang oras, yan yung magiging amount. Nagbabago yan with respect to time. And then A sub O is the initial amount or value. K will be the exponential growth or decay constant. And of course, T is our time. Kapag naman K ay less than 0 or negative, okay, so ulitin ko lang. So kapag K ay positive or greater than 0, that is exponential growth. Okay, kapag naman ang K ay less than 0 daw or negative, that is exponential decay. So alam na natin na ang growth ay um, papalaki or papadami, and decay ay papakonti. Okay? So, yung nasa left side is the graph of the exponential growth and the graph of the exponential decay. So, I think you have already studied that in your general mathematics. Now, let's proceed with our examples. All right, so we have the bacteria. Okay, so the number of bacteria in Petri dish is growing. Okay, so meron tayong clue dito, growing daw. So paparami pala yung bacteria natin. So according to the formula, N of T is equal to 25,243 e raised to 0.40, where T is time in days. Okay, so be mindful of our unit. Yung time natin ay in days dapat. Okay, so yung substitute natin sa ating T, dapat ang unit niya ay days. So note A is equal to 2.718. Okay, so that is a constant with this value. So ang tanong, what is the initial number of the bacteria? Kung mapapansin natin, itong formula natin na N, N times T is equal to, or N of T, or simply n. Baka may maglagay dyan na n times t. Simply n is equal to 25,243 e raised to 0.40. That is similar to our general formula na a is equal to a sub o times e raised to k times t. Okay? So, iniba lang natin yung sa amount, yung variable or yung letter ng amount. Okay? So, n yung ginamit kasi number of bacteria. So, pwede lang din nating gawin yan. Okay? So, let us write the equation. So, meron tayong n of t is equal to 25,243 e raised to 0.4 t. Okay, so now let us have the given. Okay, so given, meron tayong n sub o, which is the initial amount. Okay, so similar sa ating general formula, yung kasama ni E sa unahan, yun yung n sub o. Okay, so ito pala ang initial amount. So n sub o is the 25,243. So initial amount of the bacteria. And then we have decay. Okay, so wala tayong nakitang variable na k dito. Ito kasi yon yung 0.4 na kasama ng ating time. 'Di ba ang ating formula ay a is equal to a sub o e raised to k times t. So yung kasama ni t, yun yung ating k. So meron na rin tayong given, k is equal to 0.4. Okay, so the rate. So this is positive, meaning nag-grow talaga yung ating bacteria or dumadami. Okay, so this is exhibiting growth. All right. So T, okay, so mamaya, ayan, sa ating mga question, given yan. All right. So ang tanong sa number 1, sabi, what is the initial number of bacteria? Okay, so we have already our answer, n sub o is equal to 25,243 bacteria. And then number 2, sabi, how many bacteria are in the Petri dish after 3 days? So, makalipas ang 3 araw, ilan na daw yung bacteria? So, we have a given time t is equal to 3 days. And ang hinahanap ay yung n. Okay? So, simple substitution, n is equal to 25,243 e raised to 0.4 multiply to 3. Kasi in days naman na yung ating given na time and then simply substitute sa ating t. Now we will use our calculator to solve this problem. So 25,243 e raised to 0.4 multiply to 3. Okay, so as is ang pag-input, in-input ko lang yung nabuong nating equation and our answer will be 83,809 or 83,810, round ko na, bacteria after 3 days. So napansin natin, dumami yung bacteria nung nakalipas ang 3 araw. Naging 83,810. Okay? So sa number 3, ang tanong, what if t is equal to 12 hours lang. Okay, so 12 hours, ilan yung bacteria? Okay? So again, given tayo ng time, but in hours, 12 hours. So convert lang natin yan. So 24 hours in 1 day. Kinonvert lang natin yung hours sa day. Kasi nga, again, kailangan consistent sa unit. So 12 over 24 day. 12 over 24 day or equal to 0.5 day. Okay? So 0.5 yung ating gagamitin na time. So substitute lang sa ating formula, we have substitute lang again 25,243 e raised to 0.4 times 0.5. Okay? Then we have to use our calculator again. Palitan lang yung 3 ng 0.5. We get 30,831 or 832 bacteria. Okay, and that is our answer in number 3. Okay, so ang tanong sa number 4, so or letter D pala, how long will it take until the number of bacteria reaches 10 million? Okay, so iba yung given dito sa ating number 4. So yung number 4 na question, so that is the number of bacteria na. Okay, so N na yung given sa atin. And ang hinahanap ay yung time. Kung mapapansin nyo ang question ay, so how long will it take daw until the number of the bacteria reaches 10 million? So gaano daw katagal bago maging 10 million yung number ng bacteria? Okay, so simple substitution again. 10 million is equal to the 25,243 e raised to 0.4 times t. Okay, so ito na yung hinahanap, yung t. So paano natin ibababa yan? We will use the natural logarithm and mamanipulate natin yung ating equation. So divide both sides by 25,000 para mahiwalay si 25,243. So the 10 million, magkakaroon tayong 10 million over 25,243 is equal to e raised to 0.4 times t. So si t ay nasa exponent pa rin. Okay? So by virtue of the natural logarithm, pwede nating i-ln both sides. So the ln sa parehas na side. So magkaroon tayo ng natural logarithm of 10 million over 25,243 is equal to the natural logarithm of e raised to 0.4 times t. Okay? So kapag meron tayong logarithm tapos meron siyang kasama na may exponent, so pwede nating ibaba yung exponent dito sa unahan. Okay? So rewriting 10 million over 25,243 is equal to 0.4 t times ln of e. Okay, so by rules of the logarithm, so pwede nating gawin yon. So 0.40, then multiply to the natural logarithm of e. ln of e is just 1. Okay? So, 1 lang yung value niyan. So, pwede na natin siyang neglect or cancel. So, ang nabuo nating formula ay or equation ay ln of 10m over 25,243 is equal to 0.4 times t. Okay? So, ang final natin for our time is the natural logarithm of 10 million all over 25,243 divided by yung kabuuan sa 0.4. Alright? So, meron na tayong time. Substitute lang natin or input lang natin sa calculator. So, we have the natural logarithm of 10 million over 25,243 and then over or divided by 0.4. Okay? So 14.95, okay? Or yung pwede na natin siyang i-round off. So 15, ang unit natin in yung time ay in days lagi. Okay? So after 15 days daw, magiging 10 million yung number ng ating bacteria. Okay? So, and that's it for our example number 1. So, let's now proceed to number 2. Alright, so meron naman tayong radioactive substance. So, a certain radioactive substance is changing into another element according to the formula A of T is equal to A sub O is equal to E raised to negative 0.25 T, where A of T is the remaining amount of a substance after after T years. Okay? So ito naman meron tayong formula. So A of T daw is equal to A sub O A sub O times E raised to negative 0.25 times T. Okay, so meron pa rin tayong K which is negative 0.25. Okay, so meaning, so negative yung ating K or the rate, meaning as time goes by or pass by, so may kakonti yung ating radioactive substance. Okay, so this is a decay. All right, so letter A. So how much is the remaining substance after 6 years if the initial amount A sub O is 160 grams? So meron tayong given na 160. So substitute na natin sa ating general formula. So 160 E raised to negative 0.25 times T. So sabi, ilan na lang daw yung magiging substance after 6 years. So A of 6 is equal to 160 E raised to negative 0.25 times 6. And that is equal to negative 0.25 times 6. Okay, sabi T is in years, so pwede na nating direct substitute yung 6. So the amount will be just 35.7. Okay. So 35.7 grams. So dapat laging may unit. So the radioactive substance is given in grams. So grams din yung gagamitin natin. So what is the half-life of this substance? So anong meaning nun? Half-life meaning it is the time na yung amount or yung substance natin ay kalahati na lang ng initial amount. Okay? So, meron tayong given dito. Okay, kalahati ng 160 is the A is equal to 80. Bakit 80? Again, sabi half-life. So, kalahati ng initial amount. Ano ba yung initial amount? That is 160. So, ang kalahati niya A is equal to 80 grams. So, that is what we are going to use for our formula. So, we will just compute for the time again. So, given tayo ng 80 is equal to 160 e raised to negative 0.25 t. Okay, yung ginawa lang din natin kanina ay mamanipulate natin. So, magkakaroon tayo ng 80 over 160. That is just 1/2. Okay, so 1/2 is equal to e raised to negative 0.25 t. So, ln natin, both sides. Ln of 1/2 is equal to negative 0.25 t, then ln of e. Okay? And then ct natin ay magiging ln of 1/2 over negative 0.25. Okay? So, pinagbaliktad ko lang. Nilagay ko lang sa left side na equation ct and then sa right side yung natural logarithm para mas madaling makita. So, our answer will be ln of 1/2 divided by negative 0.25. Okay, so we have an answer of 2.77. Okay, so 2.77 years or approximately 3 years. Okay, so and that is our answer. Next, we have, ayan. So, pag-uusapan naman natin is about money investment. So, number 3, a money was invested with the principal amount of 75,450 pesos if the invested money is compounded continuously at annual rate of 8.7%. Okay, letter A, find the amount of money invested after 3 years. So, magkano na daw yung magiging pera niya after 3 years? And letter B, how long will it take for his investment to double? Okay, so ganun lang din ang gagawin natin. We have, ibubuoin lang natin yung ating formula. So, we have the principal amount. So, gawin ko lang P yun. P of T is equal to, initial amount daw niya ay 75,450 e raised to, ang K natin ay itong given na rate. So 8.7%, that is 0.087. So 0.0870. So move lang natin yung decimal ng dalawa para ma-convert sa decimal. So this 8.7 ay simply 0.087. Okay, so now we have our formula. Let us substitute um, the given sa ating question. So after 3 years daw, okay, so t will be equal to 3. Okay, so substitute lang natin sa ating formula. P of 3 is equal to 75,450 e raised to 0.087 times 3. So, ang magiging pera niya after 3 years ay alright, so we have an answer 97,951.28 pesos. So 97,951.28 pesos na yung pera niya after 3 years. Now, the second question, kailan daw magdodoble yung kanyang ininvest? Okay, so sabi dyan, di ba? How long will it take for his investment to double? Okay, so 2 times nitong 75,450, 2 times, so yung N natin yon, di ba? 72 times 75,450 or equal to, so 150,900. All right. So 150,900 yung N. That is equal to 75,450 multiply to E raised to 0.087 times T. Okay, again, hinahanap na naman yung T. So, divide both sides by 75,450. 'Okay? So ln both sides, we have itong 150,900 divided by 75,450. Kung mapapansin natin, equal yan sa 2. Okay? So since double daw, so we have the ln of 2 is equal to e raised to 0.0 ln then. Sorry. So ln of e raised to 0.087 multiply to t. Okay? So magiging 0.087 t multiply to the ln of e. So again, cancel out t. We get t is equal to the natural logarithm of 2 over 0.087. Again, using our calculator, we get ln of 2 divided by 0.087. And that is 7.97. 7.97 years or approximate natin as 8 years. Okay, and that is our answer for number 4. Okay, so after 8 years, dodoble daw yung ininvest niyang amount at this rate. So 8.7%. So karaniwan, hindi ganyan ang makikita nating rate of investment sa ating mga bangko. So maliit lang ang interest. Okay, so ito kasi medyo malaki na yung 8.7%. Alright. Let us have the final example. So paano kapag ganito ang ating given? Meron tayong given na table. So the table at the right shows the population P of a province where T is the time in years beginning with the year 2000. And then so on and so forth, lumilipas ang isang taon. Okay? Ang nangyayari, okay, kung mapapansin natin sa table, dumadami yung population. So increase ng time, increase yung population. So this is an exponential growth. Okay? So determine the determine the relative growth. Okay? That is the rate K. So let's write our given. So we have at time t is equal to 0 or the initial time. At the beginning, the population is 6,320. And at time t, makalipas ang isang taon, P is 6,467. 6,467. So buuin natin yung ating formula, general formula. So A of T is equal to, ang initial ay 6,320 e raised to KT. So gamitin natin yung unang taon para makuha natin yung K. So sabi, 6,467 daw yung population at time t is equal to 1. So 6,320 e raised to k multiply to 1 dahil t is equal to 1. So let us divide both sides by 6,320 para wala nang kasama si e pag ni-natural logarithm natin. So 6,467 over 6,320, that is equal to e raised to k na lang. So, pwedeng di na natin isulat si 1. Okay? Then, natural logarithm, take the natural logarithm both sides. We get ln of 6,467 over 6,320 is equal to e or k. And that is our answer already. So, ln of 6,467 over 6,320. We use our calculator to solve. And we get 0.0229 or 0.023. Okay, so 0.023 or 2.3% yung ating rate. Okay, so ang rate of increase per year ng ating population ay 2.3%. Now, meron na tayong general equation or general formula. So A of t is equal to 6,320 e raised to 0.023 times t. Okay, so yan na yung gagamitin natin throughout our equation. Okay? Okay, so ito na rin pala yung ating sagot sa number 2. So ang tanong sa number 2, general equation daw for the population P of T. Okay, so P of T pala yung ginamit. So palitan ko lang 20 e raised to 0.0233T. Okay, so dito relative growth is K 0.023. So estimate the population in 2020 daw. So 2020, ang initial mong year ay 2,000. So minus mo lang yon para makuha mo yung T. 2020 minus 2,000 and we get 20 years. Okay, so substitute mo lang sa ating formula and we will have an answer. So how many years will it take for the population to double? Okay, so population daw 6,320. Okay, madodoble again. 2 yung ilalagay natin sa okay, D, P, or P is equal to 2 times 6,320. And that is 12,640. Okay, kung mapapansin natin, sa pag nilagay natin sa equation yan, magiging 2 lang rin naman yan sa kabilang side na equation. So magiging okay, 12,640 is equal to 6,320 times e raised to 0.023t. Okay? So, cancel lang din yan. So, 2. Okay? Pag dinivide natin sa 6,320. Okay? So, 2 is equal to e raised to 0.023t. Okay? So, kapag tinatanong tayo, dumoble yung ating population, just write 2 and then e raised to dkt. And then kapag nag-half daw, half naman, edi 1/2 ang ilalagay sa kabilang side na equation. And then manipulate the equation and we are good to go. So ang sagot dyan, you may try it yourself. Okay, using the virtue of natural logarithm. Okay, ang sagot po dapat dyan ay 30.14. So, ang sagot ay so after 30.14 years, madodoble ang population. Okay? And that's it for our lesson. So, thank you for listening.